Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is classification of nanocomposites from Unit 3 Nanocomposites. On completion, the students will be able to explain about nanocomposite materials and also understand the different criteria for classifying nanocomposite materials. Nanocomposite materials are a class of materials where at least one of the faces have dimensions in the nanometer range, that is typically less than 100 nanometer. They combine nanomaterials like nanoparticles, nanofibers, nanotubes within a matrix material which is usually in the form of polymeric, metallic or ceramic type in order to enhance various properties of the material such as mechanical, thermal and electrical properties. Classification of nanocomposite materials. Nanocomposite materials can be classified based on several criteria. First, based on matrix material. Polymer matrix nanocomposites. These are most widely studied. Here the matrix is of the type thermoplastic or thermoset polymers, and the nanofillers include clay, carbon nanotubes, graphene as well as silicon nanoparticles. And applications, they have applications in automotive, packaging and also in electronics. The next type is a metal matrix nanocomposite. Here the matrix material used is aluminum, magnesium and titanium, and the nanofillers include Al2O3, SiC, carbon nanotubes and graphene. And the applications include in the field of aerospace, defense and structural components. The next type is the ceramic matrix nanocomposites. Here also the matrix materials are either oxide, carbide or nitride ceramics, and the nanofillers will be silicon carbide or Al2O3 or titanium dioxide fillers. And the applications include high temperature applications in cutting tools as well as in biomedical implants. Based on the type of nanofiller, we have the following categories of nanocomposites, such as carbon based nanocomposite, where the nanofillers are carbon nanotubes, graphene or fullerenes, and they have high electrical conductivity, strength as well as thermal resistance. And the next type is the inorganic nanoparticle based nanocomposites, where the nanofillers are silica, aluminum, titanium or zinc oxide, and they improve the mechanical strength, barrier and UV resistance. And the next type is the metal oxide nanocomposites. Here the nanofillers are silver, gold, Fe3O4 as well as zinc oxide, and they are often used for antibacterial, catalytic and magnetic properties. The next type is the polymer based nanocomposites. Here the nanofillers are made up of another polymer at the nanoscale range, and they are typically used in drug delivery and biomedical applications. Based on nanofiller geometry, we can categorize the nanocomposites as zero-dimensional nanocomposite, one-dimensional nanocomposite, two-dimensional nanocomposite, and three-dimensional nanocomposites, where the 0D nanocomposites are having the examples nanoparticles. So, nanospheres, quantum dots, and isotropic properties are under the zero dimensional nanocomposites. One dimensional nanocomposites include nanotubes and nanorods. Example, we have carbon nanotubes and nanowires. They provide high aspect ratio and are ideal for electrical and thermal conductivity. And in the case of two-dimensional nanocomposites, example is nanosheets. We have graphene and clay platelets, and it has excellent barrier properties and mechanical reinforcement. Three-dimensional nanocomposites, these are nanostructured networks. Example, aerogels, dendritic nanostructures, and they are used in energy storage and also act as catalysts. Based on dispersion and morphology, We have intercalated nanocomposites. Layered structures. These are layered structures where the polymer chains enter between the layers of the nanofillers. Exfoliated nanocomposites. Here, these individual layers of nanofillers are uniformly dispersed in the matrix and often offers superior property enhancement. Phase separated nanocomposites. Poor dispersion or incompatibility leads to separated phases. Based on the functional application, we can have the nanocomposites categorized as electrical nanocomposites, thermal nanocomposites, structural nanocomposites, biomedical nanocomposites, as well as optical nanocomposites. So, the electrical nanocomposites have applications in improving the conductivity as well as electromagnetic interference shielding. Thermal nanocomposites. It has applications in heat management. Structural nanocomposites, which include the load bearing applications. Biomedical nanocomposites, including drug delivery and scaffolds. Optical nanocomposites, light emitting devices and sensors can be obtained from optical nanocomposites. Quiz questions on classification of nanocomposites. What are the nanocomposite materials? Based on nanofiller geometry, classify nanocomposite materials. Classify nanocomposite materials based on the matrix material. Thank you.